time to turn our attention to other ways that we can manipulate routing decisions that are going to be made by RIP version 2. Now, these decisions are going to include things like weighing administrative distance. We're going to look at metric, which we've already talked about, and we've manipulated things based on an offset list, but there's also another tool that's available to us called a distribute list. Now, a distribute list gives me the capability of being able to select prefixes that I do not want to be installed in my routing table. And what we are going to find is that a prefix list, not a prefix list, a distribute list, is going to be configured such that it can work with an access list, either extended or standard access lists, or it can work with a prefix list, an IP prefix list. So what we're going to do is we're going to look at each of those in turn, starting first with an access list. Now in this scenario, I do want to still draw our attention to the fact that on R22, we have show IP route 11.11.0.0. That summary that we're advertising, that /21 prefix, and we're going to be doing load sharing right now because I've removed all configurations that have manipulated how our traffic is going to behave. So what I'm going to do is I'm going to say a trace route to 11.11.0.11, and we should load share, and we're good to go. Now what I want to do now is I want to alter this behavior. I want to specifically identify or tell the system that if I learn a prefix, I don't want that prefix placed in my routing table. And what we're going to do is it's going to be deployed again under the routing process using something referred to as the distribute list. So a distribute dash list. Now what that's going to do is it's going to say anything that I learn in the database, if it's not approved, so if it's being denied by the distribute list, do not place it in the routing table. Now the prefix that we're playing with right now is that 11.11.0.0/21. All right, so what we want to do is I want to create an access list that's going to allow me to block that. And I'm going to do it on 22, or at least I'm going to try to. So right now what I'm going to do is I'm going to create that access list, config T. I'm going to say access dash list 1. And what I'm going to do is I'm going to say permit. And what I'm going to permit is anything that's coming across from that network. So I'm going to say I permit 11.11.0.0. And now what I'm going to do is, notice I want to have the capability of using wildcards. So in this situation, what I'm going to do is I'm going to say 00.252, actually it'd be 248 because it's a /24, 255. So hopefully that's going to allow me to match. Now what I'm going to do is I'm going to go under my routing process, so router RIP, and I'm going to use a distribute dash list command. Now in the distribute dash list, it's going to give me the capability of specifying my access list. Notice it gives me a gateway feature, a prefix, gives me the ability to use my my standard or my expandeds, or even use a named access list. But we're going to right now stick with this access list that we just created, this access list 1 permit, and that's the one that we're going to go through. So now what we're going to do is I'm going to apply this distribute list, and again what we're going to realize is this is going to be directional. So what I'm going to do is, since I'm on R2, I'm going to say I want to affect this in, and specifically I'm going to say in serial interface 2/0. So what I'm going to do here is I should be able to do these manipulations. So let's take a look and see what we've got going on here. So once I hit this, do clear IP route star, show access list 1. Notice I have 2 matches. Now, what are we doing here? Let's look at this. Show IP route 11.11.0.0. Well, let's see. Right now we have a prefix that's coming in. It's being for 11.11.21. It's coming in from R2 and R3. Let's see what happens. 22, 23, 24, 26. Let's see if this resets. And it is resetting. Now what we have to do is we have to look at our configuration here. We made a single standard access list, and we did it on R22. And the idea is that we wanted to be able to filter out any of the prefixes that we're going to have coming into our interface that satisfy the access list. Now we know, show access list, we know that we're matching prefixes, and by permitting them, what we should see here is that we should have the behavior that we're looking for. So show IP route 11.11.0.0. And let's just see. Let's just give it a time. I mean, like I said, we have to be kind of patient with RIP. 27, 28, 29, 1. It's still toggling over. So it's still refreshing. Show IP route. Show IP route RIP. All right, let's take a look and see what we got here. Well, look here. We're only learning prefixes. Well, there's one. From 2.0 for pretty much everything. Here we're learning these prefixes. So the net result here is it looks like I'm permitting serial 2.0 and 2.0.1, but notice those are the only prefixes that I'm learning anything about. So looking at this, show access list, I'm matching on this network, and it seems to be the only interface that I'm aligned to come through, or the only prefix I'm aligned to come through. And just as a verification, show run section router, I applied it to serial 2.0. Well, the issue here is I need to look at my logic. Show run pipe include access dash list. And my logic says to permit 11.11.0.0. And what we need to realize here is that we're also running into an idea where we have the concept of the implicit deny at the end of this access list. Now, in the lab, I recommend to students that you go ahead and make the implicit deny and explicit deny on the majority of your configurations, because the implicit will not give you any feedback in the show IP access configuration, IP access list, or show access list. So if we go in and we do this, this should give us the ability to be able to see what's actually happening. So config T, what I'm going to do is I'm going to say access list 1 deny any. Do clear IP route star show access dash list. Notice now I've got 42 matches. So I'm blocking a lot of stuff. Now the reason that this is happening is I have actually messed up my logic. So rather than deny or permit, let's see what happens if I deny. So what I'm going to do is I'm going to say config T no access list 1. Then what I'm going to do is I'm going to come in here and I'm going to say IP, or I'm going to say access dash list 1 deny 11.11.0.0.0.248.255 access dash list 1 permit any. I just reversed my logic. Do clear IP access list, not access list, what am I doing? Show IP, do clear IP route star, show access dash list. Now what we have here is we're matching, we have 2 matches and 42 permits, 63 permits, and in 30 seconds this should change. Just got to be patient. Something I don't win any awards for. So while we're waiting for it, let's take a look and see what's happening now. So show IP route 11.11.0.0. Notice now we're only learning the prefix from serial 2/1, metric 3. Now when we look at this, what's happening here is the access list, show access list, is matching this specific network, and it's denying its ability to be taken from the database and placed inside of the routing table. Now, the permit any is allowing all other interfaces or all other prefixes to pass. Let's take a look at this. Show IP route. And now what we should see is we're learning interfaces from 2.0 and from 2.1 for everything except the 11 network. There it is. The 11 network. Now we're only learning it from 2/1. Now we're filtering on 21. So that means that's 8 prefixes. So what I'm going to do is I'm going to go to R1 and I'm going to add a new loopback. So show IP interface brief, exclude assigned addresses. So that would be config T interface LO 08 IP address 11.11.8.11.255.255.0. Show IP protocols. It should automatically start advertising or be advertised, participating in RIP, which it is. So now when I go over to R2 and take a look at what's happening for my 11 networks, show IP route, RIP, hopefully we will see that I'm learning the 11, 11.21, and I'm learning the more specific 11.11.8.0.24, still learning them from this idea of 2/1. So let's see what happens over time. Show IP route 11.11.8.0. So far all I'm seeing is 11.11.8.0. So let's do this. Show IP or show access list. So that's 8. So it's outside of my summary. So it should be advertised. Notice here we have the 12 matches. Now what I want to do is I want to see these matches. I want to know exactly what's happening. So what I'm going to do is I'm going to modify my access list. I'm going to say IP access list standard 1, and I'm going to hit enter. And what I'm going to do is I'm going to modify this access list. First of all, I'm going to say no 10. I'm going to say 10 deny 11.11.0.0.0.248.255. What I'm going to do is I'm going to say I want to log it, which means every time it gets matched, it's going to put a message on my console. So clear IP route star and see what happens. Okay, 11.11.0.0 was denied on 0.0.0.0, and it was just one packet. Now the question is am I advertising the prefixes throughout my infrastructure? So let's go to switch 2 and switch 1 and see what happens here. So show IP route 11.11.8.0. There it is. Show IP route 11.11.8.0. There it is. It's being advertised as a /24. So let's go up to R2 and R3. Show IP route 11.11.8.0. There it is. 3. Show IP route 11.11.8.0. We're learning it from .12, which is switch 2. On 2, we're learning it from 11, which is switch 1, or cat 1 and cat 2. Now let's cut over to 22. Show IP route 11.11.8.0. And now what here is happening here, we're only learning it from serial 2/1. Now oddly enough, our filter is kicking or hitting our next prefix. So let's look at this. Show IP, show run, section router. Okay, we've got distribute list. It's calling access list 1 coming in from serial 20. Let's remove this just for a minute and see what happens. Config T, router, RIP, no, distribute list, clear, IP route star, show IP route. Let's see if this brings everything back to the way we want it. And here we are. So notice we're load sharing. Oops, didn't mean to bump that. So here's our 11s, 21 and 24. Now the issue here is that when we go through and we look at how this is implementing, we should be looking at 21s, which gives us 8 prefixes. That should be 11, 0, 1, 2, 3, 4, 5, 6 to 7. But the moment I apply that access list on this interface, I'm actually taking out 8. It's not appearing in my routing table for serial 20. Now that's not what we wanted. What we wanted was, as we said, we only want to receive the prefixes. We only want to receive the prefixes that have been summarized. So I should only be blocking the /21s. Now we have a tool that's better suited for being able to do this, and that tool is going to be prefix lists. Now, before we move into looking at this, the other thing I want to illustrate here is the fact that we also have the capability of being able to affect how we're going to learn specific prefixes using this distribute list. So what I'm going to do is I'm going to go back over to R1, and I'm going to take off my summarization commands. So do show run section router. Go ahead, config T. Interface E00, do show run interface E00. I'm going to say no IP summary address. Do the same thing for 01. Do show the interface E00, interface E01, clear IP route star, and now let's go back over to 22. Show IP route, pipe include 11.11. Okay, there's the prefixes that we're learning. So far, everything's coming in from 2/1. Let's make sure I've got everything configured the way it's supposed to be. Show run interface E02. Oh, serial. Serial 20, 21. No manipulations there. Show run section router. Nothing there. Let's double check on to show run interface serial 20. Do show or show run pipe section router. And lastly on, well, should have been doing that on R2 anyway, sorry. Show run interface serial 20. Show run section router, and lastly on R3. All I'm doing is just verifying my configs. Show run interface S21. Show run section router. All right, so let's cut over to SW or R22 and let's see what's going on. So the issue here is I'm still matching packets. And notice it's telling me it's specifically denying this one. So what's going on here? Show IP route, RIP, show IP, show run section router. no auto summary, network prefix, show access list. Well, here I'm still denying traffic. But the question becomes, why? Well, the answer lies right here, and the fact that we're using wildcard masks. Now, what I did is I said that I want to use 248. Now, what's happening here is 248 says that I'm going to advertise every 8th network, starting at 0. So it's going to advertise, or actually in this instance, it's going to deny 11.11.0. It's going to deny 11.11.8. Now what I'm going to do is I'm going to remove this access list. So I'm going to say config t no access list 1. Do show IP route 11.11.0.0. Let's see what we got. Now we're load sharing 8.0. All right, so everything's the way we would normally would want it. So if I did a trace route, do trace route to 11.11.8.11, it's going to load share. So we see that we're sending the information the way that we want to. Now before, when we did the distribute list, I'd screwed the logic up. I wanted to deny, but now what ends up happening is I need to understand exactly how I can increment my topology. So right now, let's look at what's going on. So when I do my show IP route, I'm going to see individual prefixes for all of my 11s, and they're going to be load shared across the two interfaces. Now what I'm going to also want to do is I'm going to want to do the manipulation such that I'm going to say, well, I really don't want the first 4 to be installed using serial 2.0. So I don't want to learn 11.11.0, 2, 3, 0, 1, 2, and 3 from serial 2.0. So let's return to our logic here. So what we wanted to do, first of all, is I want to block these interfaces. So what I'm going to do is let's create that access list again. So do show access dash list. Let's make sure it's gone. Access dash list. I want to deny, and the network I want to deny is 11.11.0.0. But what I want to do is I want to, again, recognize, let's see, IP access list 1. Deny 11.11.0.0. And again, what I want to do is I want to deny using my wildcard bits. So what would happen if I come in here and said /21 log? Do show access dash list 1. Well, notice what it did. It didn't use 248, it used 7. And that's what I'm trying to illustrate here. When we use wildcard masks, the logic is reversed. So we would be putting a value of 0 to 3. It would be 3 for 4 options. It would be 7 here for 8 networks. For our 16 networks, it would be 15. So when we look at this, what's happening now is it's going to say, okay, I'm going to add 7 to that 0. So that third octet is going to add 7 to. So it's going to be 11.11.0, 11.11.1, 11.11.2, 11.11.3. And now if I do my configuration and I do it properly, router RIP, distribute list, 1 in serial, and I said that I wanted to not learn prefixes from serial 2.0 for the first 4 networks being advertised by R1. So let's see here, do show access list. Well, I've already got a problem. I need to add my permit. So now what we do is we say access list 1 permit any do show access list. Okay, let's see what we got now. We've matched 11, 11.00, 11, 11.2.0, 11, 11.3.0, 11, 11.4.0 do show IP route. Scroll down till we get to the 11s. What we see now is we see that we're old on these. So all I'm going to do is I'm just going to expedite this process. I'm going to say do clear IP route star. We'll wait for our refreshes and our updates to come back through. But even with a standard access list, you can see we've got a lot of granular capability. Now what I did is I said that I wanted to block the first 4 networks, but I did not want to block that 5th one that we're advertising, nor did I want to block 8. So when we go in and we look at this, show IP route, let's see what our table tells us. So let's see, 11. All right, so here what we see. We have the first 4 networks. So 8 we're learning, and we're learning 8 via the 2 interfaces, but right now we're only learning the first 4 from 2/2. Now, when we look at this, let's take a look at our access list again. Show access dash list. Well, we've got the 30 matches, and we are logging. So we should see those updates coming in. So let's clear it again. So clear IP route star, and let's wait and see what's being denied. We just have to be patient. Again, not one of my strongest suits. Now while this is happening, hopefully it should come through. Got 50 matches. Show IP route. Clear access list counters for 1 show. There we go. And what we see here is, notice it's denying 11, 11.00, 11, 11.1, 11, 11.2, 11, 11.3, and 11, 11.4, but it's letting 8 through. Trace route to 11, 11.8, 11, and notice it's still going to be load shared, whereby when I hit 11, 11.0, 11, it's going to only go through R3. So we've done the base manipulations. There's only one other element I want to cover here, and that's if I want to change the behavior of how I learn my prefixes. Let's look at this. We're advertising 4, actually we have 6 prefixes that we're advertising into RIP. Now how would I do this if I wanted to say, okay, through, let's write this down so I don't get confused. All right, let's say from R2, I want to learn all of my even prefixes. And from R3, I want to learn all of the odd prefixes that are being advertised. Now I know we're going into depth inside the context of RIP, but what I want you to keep in mind is these processes are going to be almost identical for every other routing protocol that we're going to be talking about. And since RIP is so simple, it's a perfect opportunity for us to begin to explore these capabilities and play around with it, because we're not having to worry about any of the advanced features that we have, say, in a link state or an external gateway routing protocol like BGP, or a link state like our OSPF. So let's play around with this last element here. So what I want to do is I want to have a standard access list, and that standard access list is going to allow me to filter all prefixes that I'm going to be learning, but I want to filter them based on a value located in the 3rd octet. So we have x.x.somevalue.x. Now all I'm concerned with is this 3rd octet. So if it's even or if it's odd. Now, how do I filter on evens and odds? Well, In the scenario that I want to look at right now is I want to be able to do filtering of all routes that's coming in that I'm going to have an even number in the third octet. Well, an even number means I'm going to have to, one, count by twos, and if I count starting at 1 and add to it, that's going to be 1, 3, 5, 7. So you can see that calculation is going to give me every odd octet. So let's take a look at what we've got. And what we're going to do is we're going to use the implicit deny here to our benefit. But I'm going to make the implicit explicit. So let's take a look at what happens. So first of all, let me get rid of the current configuration. So config T, no, access list 1, router, RIP, do show run, section, RIP, no, let's take care of the distribute list. All right, now, with this removed, what I want to be able to do right now is I'm going to say I'm only going to allow my evens to come through. So the way I would do that is I would say, first of all, my access list. Access list, we'll go ahead and say access list 1. Let's make sure access list 1's gone. Do show access dash list. It's gone. So access list 1, and I want to match on this value here. Anything, anything. So the only thing I'm concerned with is the third octet, and for me to get even values, so if I want to match on the even numbers, I'm going to add this value of, let's see, we'll talk with 1, let's see, no, 1. So we're going to start at 1. And then I don't care about the third octet. So how do I do my counting? Remember, it's an access list, or I'm sorry, it's a wildcard. So I'm going to match on 255, 255. And if I want to count by twos, what number do I subtract from 256 to give me 2? 254. And I also don't care about anything in that third octet. So now what I want to do is come back up to my router process, router RIP, and I'm going to say distribute list, and I'm going to apply list 1 in on serial 0 or serial 2, 0. Now let's see what happens. I also said config T, I was going to do an explicit deny. Deny any. Do show access list. Well, I've got some matches coming in now. Clear IP route star. Show IP access list. Show IP route. And let's see what we've got going on. I'm going to go ahead and erase my configure my writing over here. And let's pay attention to the 11's prefix. So 1111, pay attention to 2, 0. Reachable through 2/1. Now I said I wanted to learn all of my evens through my link to R2. So let's try another even one. Let's see, 4 for 21. Let's try 8. So when I look at this and I take my configuration here and I show my access list, we have a problem. The access list is permitting anything, but if I add 2 to 1, so let's go through and start our count. So right now I start at 1. If I add 2 to it, I get 3. If I add 2 to it, I get 5. If I add 2 to it, I get 7. If I add 2 to it, I get 9. So what's happening here is that I'm using the wrong starting point. So what I want to be able to do is say, I don't care anything, anything. But then when I take my 2, it's going to take 0, add 2 to it, which is going to be 2, 4, 6, and 8. So now let's see if we can change this behavior by modifying this access list. So what do we need to do? Well, let's do this. Show, run, pipe, include, access-list. And I'm just simply going to say config t, no access list 1. And what I'll do is I'm just going to modify this. So I'm going to say zero. Okay. Now when we take a look at this, I'm going to say access list 1 per deny any. Clear IP route star. Show access dash list. So we got 36 matches. So let's take a look and see what we got going on now. So show IP route RIP. All right, let's look at these from the point of view of evens and odds. So show IP route 11, 11, 2, 0. Well, according to this, I'm load sharing still. So we've got 2 and 1. Let's see what happens with our timers. Timers seem to be resetting. Show IP route, pipe, include, and I want to see what I've learned from serial to 0. Well, this is interesting. Look here. The only thing I'm learning are even prefixes. Let's look here. Let's modify it and say serial 1. If we look here, I'm learning everything. Well, the problem is this. When I did my list, I said 0, 0, 0, 0, and I did 255, 255. This means don't care. So what it's doing is it's actually affecting every prefix on on serial 2/0. Now the reason being is I should have specified 11s because those are the only prefixes that I want to manipulate. So let's fix that. So again, let's edit our access list. Show run, pipe, include, access-list, and we need to fix this part right here. So here's what we'll do. Config T, we'll just edit it. So IP access list standard 1. What I'm going to say is I'm going to say no 1. Hold on here. Do show access list. It should be 10. Yeah, no 10. Then what I'm going to say is 10 permit 11 11 0 0 0 0 254 255. Do show access list. Do clear IP route star. And actually what I'm going to do is I'm going to say router config or router RIP, and I'm going to have to create another access list. So this access list will be for the evens. So here what we'll say is access list 2 permit 11.11.0 11.11.1 0 255 no 0 0 254 255. Access list 2 deny any router RIP distribute list 2 in serial S21. Clear IP route star show IP route pipe include serial 20 even see even show IP route pipe include serial 21 odd and odd. So let's take a look at our access list now. Show access list 1 show access list 2. Now we've got 8 matches. So now let's see what ends up happening. Trace route to 11.11 to 11. I'm going out R2. Trace route to 3.11. I'm going out R3. So what we've done is we've used the distribute list to block prefixes being installed in the routing table. We've used it to block evens and odds. We've looked at how we configure our access list with regard to the fact that we're using wildcard masks. And it's important that we understand that if we use something like 252, what's going to end up happening is that that's going to actually skip by a value of 2. So 256 minus 254. And then what you're going to find out in that scenario is it's going to be, well, it'll actually be in increments of 4. So 256 minus 252 is going to give me a value of 4. So that's going to give me the count that I'm going to use. The other part of this is that we also need to realize the fact that when we use, say for instance, 0.0.7.3.15, that's going to be taking the first 15 or the next consecutive 15 or next consecutive 4 or 8 from where we tell it to start counting. And we saw how we can use a 0 or a 1 in order to be able to start to get the calculation such that it's going to be the evens or it's going to be the odds. All right, with that said, I'll see you guys in the next part of our presentation where we're going to again continue working with this idea of prefix filtering.